Hello, AP Physics 1, it's Mr. Ng, and here is Chapter 4, number 13. This goes out to Victoria, who asked for this. So this is the question: an elevator with a mass of 4,850 kilograms is designed so that the maximum acceleration is 0.680 g. Don't be confused, this g refers to gravity, right? So it's like 7% of gravity. What are the max and min forces on the motor? So a couple of steps that we're going to do. We're going to first do a free body diagram. And then we're going to use Newton's second law, F is equal to m times a, right? Or F net is equal to m times a. And then we're going to solve. Seems simple enough. So let's start with the free body diagram. We have an elevator. And we know that one force has to be mg. And then the force of the actual motor is going to be the tension. And overall, we have sometimes the motor working really hard, pulling it up, where the acceleration is going to go up this way. And the acceleration is, again, 0.0680 g, right? This is going to be the max. And every now and then, it's going to go downwards, 0.0680 g. This is when ft is doing the min. So really, the trick to this problem is knowing how to set up Newton's second law, right? And let me show you how to do that right now. So let's do it for the max. For the max, we say that F net is equal to, and then we need to sum up these forces appropriately. So in the max, the thing is going up, the elevator is going up, so Ft is larger. So I'm going to start with Ft first. Just trust me on this. I thought about like messing with the signs to teach you the best, but I think this is going to be the simplest method. The bigger thing should always go first. So Ft minus mg is equal to the overall mass times acceleration, right? We could get rid of F net, so now we have the tension minus the force of gravity is equal to m times a. The tension is the actual force that it wants. The force of the motor is this tension. So now I just have to solve for Ft, meaning Ft is equal to m times a plus m times g, right? I just kind of move that stuff over. And I'm still going to start plugging in. is this A, so 0.0680 G, right? Plus M of regular old G. So that adds together. That means that Ft is equal to 1.0680 G. Some of you might be a little goofed up by that math. You know, like 1x plus 2x is 3x. All I did was add them, right? This is 1g and 0.07g. So I just kind of added them together. And now I could plug in to solve. So Ft, the force of that motor, is 1.0680 times 9.8 times the m is this sucker right here, 4850 kilograms. All right, this is mass, meters per second squared. If you punch in all that math, I got 50762 newtons. That's not sig figs. We're given basically 3 digits, so I got to reduce it down to 3 digits, equals to 5.08 times 10 to the 1, 2, 3, 4, times 10 to the 4th newtons. Good, so this is our max force. Let's do our min force. Our min force, that means acceleration is going down. So the setup is going to be a little bit different. Contrast this one is how we did the first one. Let's do again F net. So if it's minimum, that means it's going to go down, right? It's going to go down. If it's going to go down, then I'm going to start with mg instead. Mg minus ft, right? Mg is bigger, is going to be m times a. Does that make sense? That makes all the difference. This little change makes all the difference. Just trust me here. So I don't need to worry about F net. That means nothing. So here, mg minus ft, and I want to solve for ft. This is the force of the motor. So negative ft is equal to ma minus mg. I'm going to multiply everything by negative 1. That means ft is equal to negative ma plus mg. I'm just going to switcheroo that. ft is equal to mg minus ma. Notice how the math is now slightly different, but I could still plug in is equal to mg minus m times 0.0680 g. So ft is equal to 0.932 g times m, right? So I could solve now. 0.932 times 9.8 meters per second squared times this gigantic mass, which is 4850 kilograms, and I get my raw number is 44298 newtons. But of course, sig figs and scientific notation, I'm going to rewrite that as 4.43 times 10 to the fourth, not 3, newtons. All right, this is my min. Okay, so here is our answer in the middle. Biggest trick here is knowing how to work Newton's second law, the F net thing. And notice how there are slight changes when we're going in two different directions. And that is going to be huge, especially when you guys do your lab. You guys are working really hard. Thank you so much for watching this video. I get like 4 views on this thing, and you are one of those 4. So thank you.